and welcome to the ICSE 10 Maths tutorial. एक शायर की दो लाइन सुने. शायर कहता है, तुम खतावारों में हो, तुम खतावारों में हो, हम भी खतावारों में. तुम खतावारों में हो, हम भी खतावारों में हैं. कौन दे किसको सजा, सब तो गुनहगारों में. Okay, now let's start. Today's topic is linear inequations. In the ICSE board examination, from this chapter, linear inequations, one question is asked for 3 marks. There are some important points that we need to keep in our mind. Very small point, but you may lose marks if you don't keep those important points in your mind. So let's start. First of all, let me tell you the difference between equation and inequation. 2x is equal to 7 I have written. This is an equation we are familiar with. We are familiar with this. 2x is equal to 7 is an equation. 2x is less than 7. 2x is less than or equal to 7. 2x is greater than 7. 2x is greater than or equal to 7. Is less than or equal to, is greater than or equal to, they are inequalities. And so 2x is less than 7 is called an inequation. Is less than or equal to is an inequality, and so 2x is less than or equal to 7 is called an inequation. This is equation, this is inequation. Alright? Like that, they are the inequations. Okay. Now here are the important points. The first point is, I have taken one example, 2x is less than 7. One inequation I have taken, 2x is less than 7. What I am doing, I am adding 4, same number 4, on both the sides of the inequation. Here it is less than, I am adding 4 on the left side and on the right side. This inequality remains the same. Here it is less than, here also it is less than. Alright, we are adding 4, the same number. We are adding the same number on both the sides, but then also the inequality remains the same. Alright, so we can frame a rule. The rule is, if same number is added on both sides of the inequation, then the inequality remains the same. The inequality remains the same if the same number is added on both sides of the inequation. So this side also 4, this side also 4 we have added, but the inequality remains the same. Less than remains less than. Here we are subtracting. The same inequation I have taken, 2x is less than 7. Here also 2x is less than 7. Here also 2x is less than 7. 2x is less than 7. And I am subtracting 4 from both the sides. See the inequation. The inequality is less than remains is less than. Is less than remains is less than. I am subtracting 4 from both the sides. So the rule is, we can frame the rule. The rule is, if you subtract the same number from both sides of the inequation, then the inequality remains the same. Okay? Fine. Now third point. I have taken one inequation, x upon 2 is greater than or equal to 1. What I am doing, I am multiplying by 2 positive 2 plus 2, both sides of the inequation. Both sides, left and right, both sides I am multiplying with the same positive number. Here it is 2. What's happening? Is greater than or equal to remains the same, is greater than or equal to. It remains unchanged. So the rule is, if you multiply both sides of the inequation by the same positive number, then the inequality remains the same. It does not change. Okay, same positive number if you are multiplying. Now the same is true if you are dividing both sides. See the example here. I have taken 2x is greater than or equal to 1. One inequation I have taken. What I am doing, I am dividing both sides, both the sides of the inequation by 2. I am dividing by 2. So 2x upon 2 and 1 upon 2. So 1 upon 2 here and 2x upon 2, 2 cancel, you are getting x here. Okay. What's happening? You see, is greater than or equal to remains the same, is greater than or equal to. That means the inequality doesn't change. The inequality remains the same. So the rule is, we can frame the rule. The rule is, like here in the case of multiplication, alright, when you are multiplying by the same number, positive number, both sides, the inequality remains the same. Similarly here, when you divide both sides of the inequation by the same positive number, here fortunately 2, again 2, by the same positive number, you are dividing. Again the inequality remains the same, it does not change. So in all these cases, first, second, third, fourth, the inequality does not change. You are adding same number, both the sides, you are subtracting same number on both the sides, from both the sides you are subtracting, you are multiplying by the same positive number, both sides, you are dividing both sides of the inequation by the same positive number. Alright. Now see the fifth point. Sorry. In the fifth point, what are we doing? See, I have taken one example. Minus x upon 2 is greater than or equal to 3 upon 2. This inequation I have taken. And what I am doing, I am multiplying by the same negative number, minus 2 and minus 2, by the same negative number. See, 3 by 2 as it is, minus x upon 2 as it is. And I am multiplying by minus 2, the same negative number. Right? Both the sides I am multiplying. What's happening? See, is greater than or equal to is becoming now is less than or equal to. Got it? So that means, so we can frame the rule. The rule is, when you multiply both the sides of an inequation, when you multiply both the sides of an inequation by the same negative number, then the inequality is reversed. Is greater than or equal to is becoming is less than or equal to. And the same thing is true when you divide. When you multiply by the same negative number, both sides, the inequality is getting reversed. Similarly, when you divide both sides of the inequation by the same negative number, again the inequality is reversed. So in both the cases, multiplication and division by the same negative number, whether you are multiplying both sides by the same negative number or you are dividing both sides of the inequation by the same negative number, in both the cases the inequality is reversed. Important, very important. Here only there are some students who make mistake here only. And once you make any mistake here, that means your solution set is going to be wrong. And once the solution set is wrong, even if your plotting is correct, you will lose mark here. So then you lose mark here also, 1 mark for solution set, and the third mark, because 1 mark is for this, for solving the inequation and getting the relation like x is less than or equal to minus 3 here, or x is greater than 2, or x is greater than or equal to minus 3 upon 4, whatever. So for this much, actually what we do in the board examination, that I'm not telling you, in the home examination for the entire thing till here, we give 1 mark. In the board examination for any, for transposition only, correct transposition, we give 1 mark. Correct transposition, for example, all x's together and then all constant together. Alright, suppose here you have plus 2, so that you are transposing from left side to the right side. Right, so plus 2 is going here and becoming minus 2. So minus x upon 2 is greater than or equal to 3 upon 2 and minus 2. So for only correct transposition you are given 1 mark. Alright, and then you reach till here. Then after that you write down the solution set. For that you get the 2nd mark. Solution set has to be correct. The curly bracket, and then there are so many things that I'll tell you in my next video when I solve the question. When I solve the questions, there I'll explain to you what are the important things that you have to show in your solution. All these points I'll explain to you in that solution. How you are going to keep in mind all these things, and then you are giving the solution. Okay. So 6th point is to write down the solution set. There are 2 ways. One, rule method. Second, listing method. That depends whether x belongs to R or x belongs to other than R. If x belongs to R, then rule method. And if x belongs to other than R, for example, x belongs to n, the set of natural numbers, x belongs to z or I, x belongs to w. Alright, so in all these cases, you have to write down the solution set in listing method within the curly bracket. Alright. Okay, so you have to write down the solution set. You remember here how to write down, what are the important points that you need to keep in mind, the curly bracket, the comma, this in the case of rule method. Then you have to write down x belongs to R. There are so many things that I'll tell you in my solution when I solve the question in my next video. Then after writing down the solution set, you plot those values from the solution set, you plot on the number line, real number line. Okay. Now what I want to tell you in point number 7 is, one extra number on either side you have to show. For example, you are getting solution set as 1, 2, 3. Your solution set is 1, 2, 3. For some questions, some values. For some inequation you are solving and you are getting the value, solution set as 1, 2, 3. So 1, 2, 3. That's your solution set. You are writing solution set. You are solving and then writing solution set as 1, 2, and 3. Now what you do? So 1, 2, and 3. Alright. For any inequation given, you solve and you got the values of x, and then you wrote the solution set like this. This is correct. You got correct. Solution set is 1, 2, 3. Now you have to plot these values on the number line. You plotted 1, 2, 3. One extra number on the right side, one extra number on the left side. It's very, very important. Very important means if you don't write down, you lose marks. Now very, very, very and very cube, whatever you understand, if you do not write down these extra numbers on either side, you lose mark. If you do not show this arrowhead on either side, then also you lose this mark. Alright. So like that you have to, like that you can represent the solution set on the number line. There's one more important point. When you are writing down this, when you are given x belongs to R, and you are writing down the solution set, and suppose you are getting x is less than or equal to 5 upon 2. Okay, 5 upon 2 suppose. So first thing is, you should not write down 5 upon 2. You should write down 2 1 upon 2. Please do not write down in improper fraction. Write down in mixed fraction or in decimal. Decimal I don't write down, because in some cases you can write down. When it is a recurring decimal, then you cannot write down. In recurring decimal, you cannot write down in decimal. Alright, so this is the better way. In all the situation, you can write down, you can use the mixed fraction form. So improper fraction you write down in mixed fraction, or if you are very much clear that it is a terminating decimal or it is a non-terminating decimal. So if it is a terminating decimal, then you can write down in decimal also, but not for non-terminating, not for the values like 1.33333, and so if you are writing 1.3, that means some of the 3's you are missing. Alright, you are discarding, you cannot do that. So in that case, you should write down in mixed fraction form. Alright, so 5 upon 2 is not accepted, not at all. You have to write down either 2 1 upon 2 or 2.5. I write 2 1 upon 2. Now, if in your question it is given that x belongs to R, then you have to show this 2 1 upon 2 here on the number line. You have to show here in between. 2 1 upon 2 will fall in between 2 and 3. Alright, so here somewhere you have to show 2 1 upon 3. In that case, the representation will be different. Alright, because here this solution is for the listing method. Alright, when x belongs to other than R. When x belongs to R, in that case, you have to write down, you will write down the solution set in rule method, and in that case, this is not the way you are going to represent the solution set. In that case, you have to shade the entire region. In that case, you have to shade the entire region like this. Like this, suppose 1 is here, 1 is here, and then one extra number, and then you shade. And then if this is less than or equal to, then you have to shade this. If it is only less than, then you keep it blank. This side also, if it is greater than or equal to, then you shade it. Alright, and if it is, alright, and then you take the entire region like this. So all these things I'll explain to you when I solve the question in my next video. I think a detailed explanation is required for this. What happens when x belongs to R, how to represent the solution set on the number line, and how to represent the solution set on the number line when x belongs to other than R. Other than R is this. Other than R is this. In that case, you have to list the solution like 1, 2, 3, and then you represent here. When it is x belongs to R, in that case, you shade the entire region, but then you have to see so many things. You have to see this side if it is less than or equal to, or it is only less than. If it is only less than, then you have to keep this blank. Alright, come this side if it is greater than or equal to. So if it is equal to also, greater than equal to, then you have to shade this. You have to dark this, right? Darken this, fine. So all those things I'll explain to you in my next video when I solve the question on this. And these are the important points, 8, 9 points. They are very, very important points. Please keep in mind. And I hope things are very, very clear. In my next video, I'll solve a few questions and I'll try to explain to you all these points, how we are applying all these points, how we are keeping all these points in our mind when we are solving question, when we are writing down the solution set, and when we are representing the solution set on the number line. I hope things are very, very clear. Okay, one replacement set also, that one term, that also I'll explain to you, but in my next videos. So I hope things are very, very clear. So before we end, ख़त्म करने से पहले आपको एक जोक सुनाता हूँ. एक टीचर ने एक बच्चे से कहा, मैथ्स का पीरियड था, तो टीचर ने बच्चे से कहा कि अच्छा बताओ भाई, अगर तुम्हारे अंकल को मैं 500 रुपीज़ दूँ, 500 रुपये दूँ और उन्हें सिर्फ 400 रुपयों की ज़रूरत हो, तो वो मुझे कितना वापस करेंगे? बच्चा बोलता है, एक पैसा भी नहीं सर। टीचर को बड़ा गुस्सा है। टीचर ने बच्चे से कहा कि तुम मैथ्स नहीं जानते। तो बच्चा बोलता है कि सर आप मेरे अंकल को नहीं जानते। ओके, हंसते रहिए, खुश रहिए। थैंक यू सो मच। थैंक्स।